Let's take the derivative of the arc cosine of the absolute value of x. And we can actually rewrite this because absolute value of x is a shorthand for square root of x squared. And another way to say that is x squared to the 1/2 power. So let's copy and paste this and rewrite it just like that. Rewrite it using this. So now that we've rewritten arc cosine of the absolute value of x, it's pretty clear that we're dealing with nested functions. We have x squared, which is nested within the square root function, represented by the 1/2, and we have all of that nested within the arc cosine function, which means we're going to be using chain rule, and we're actually going to be using chain rule twice. So we'll start by saying x squared is the innermost of the nested functions, so we'll say u equals x squared. And let's take the derivative of both sides. So derivative of y equals derivative of arc cosine of u to the 1/2 power. Just replacing u into this function up here. So now we have a function in terms of u being differentiated with respect to x. So let's fix that by saying the derivative of u with respect to x is going to be equal, well, the derivative of x squared is just 2x. So let's rewrite this whole thing. Just another copy and paste job. We can rewrite this as du dx times d du of this whole thing. But we still have u to the 1/2, which is nested within arc cosine function. So we're going to use another substitution, and this time let's use w. So w equals u to the 1/2. And let's bring this whole thing down. And all we did is replace u to the 1/2 with w. Now the same thing happens is here, is that we are differentiating a function which is in terms of w with respect to u. So we're going to use chain rule again, and we can use the same process as we did up there. And we can say the derivative of w with respect to u is going to be equal to, bring down the 1/2, so we have 1/2 times u to the 1/2 minus 1 is negative 1/2. So we can rewrite that as 1 over 2 times the square root of u. So let's clean this up and just replace that. So we have dw du equals 1 over 2 times the square root of u. So we can do the following. Well, first we're going to copy this again and bring it down. So we're going to multiply du dx times dw du, which we just solved for, times d dw. That is not a w. Times d dw. And notice that this dw crosses off with this dw, and this du crosses out with that du, so what we're left with is the derivative with respect to x of arc cosine w. So it's a kind of an interesting extended chain rule. And now it's just going to be a matter of bringing down these derivatives we took and undoing substitutions. So derivative of y equals, we already said that du dx is going to be equal to 2x. So let's replace that. 2x times derivative of w with respect to u, we already said is going to be equal to 1 over 2 times the square root of u. So times 1 over 2 times the square root of u. And then the derivative of arc cosine of w, we solved in the main derivation video that the derivative of arc cosine is negative 1 over the square root of 1 minus w squared. Looks like these 2's are going to cancel out like that, and this x times 1 is going to be x, times negative 1 is going to be negative x. So let's do that. And let's bring this u over. This multiplication is just going to give this denominator a u coefficient, square root of u coefficient. And I'll rewrite that whole thing so it's a little neater. dy dx equals negative x over square root of u times square root of 1 minus w squared. And we're going to want to get everything back in terms of x. So u is equal to x squared from up here. U equals x squared. And w is equal to u to the 1/2, which we get from here. Which is going to be equal to x squared to the 1/2, which that looks like the absolute value identity that we had up top. It's just a shorthand for absolute value. Or rather, shorthand, absolute value is a shorthand for this. So let's see, we have derivative of y with respect to x is equal to negative x over square root of x squared. So look, another absolute value is popping up. Square root of x squared times square root of 1 minus x squared to the 1/2 squared. And so the absolute value squared, something squared is always a positive, which, you know, just for intuition means that we're going to not have to deal with an absolute value sign under this. But this 1/2, if you square it, that's the same thing as saying for exponents, that would be 1/2 times 2. So these cancel out and equal just the 1, which we can forget because that is that's the same thing as just saying x squared. So we can actually get rid of these parentheses. It's going to be the square root of 1 minus x squared. This is the square root of x squared, which is the absolute value of x squared if you'd like to write it like that. And it looks like we are done.